Hello and welcome to everybody to our webcast about BeeGFS Easy Data Management for everyone. Today we will mostly talk about remote storage targets, how to configure, how to use them, and also want to show a small demo where we can see how this is configured, what it needs to be set up, and how to handle this and how the system behaves if I do this. We have the opportunity to ask questions, so you will find in the Zoom session an Q&A window, and if you have any questions, please don't hesitate and write this down. We will answer this during the end of this session. Otherwise, it was a bit challenging for me to see what's going on there. I'd like to start right now, and as we have a lot of things to do, so I want to go quickly with this. What about BeeGFS? You know BeeGFS maybe already, and you know BeeGFS is the solution that is focused on performance, scalability, and robustness. And with version 8, BeeGFS version 8, that is out now for a little bit more than a half a year, we added some data management functionalities. Mostly of them are working with a data management API that we have integrated with BeeGFS version 8. And this means the functionality that we are talking today is something that is completely built outside of the BeeGFS core. That means the BeeGFS core file system metadata storages are not really affected from this. There are some extensions in the metadata fields on the metadata service itself, but there is no, I would say, fundamental change in the metadata or storage structure. This helps us to keep the file system as small and performant as possible and not overwhelming this file system functionality with additional features. For this, we use an API so that everything that happens around with data management features will be something that acts more or less as a client if you look at it from a BeeGFS perspective. With BeeGFS 8, the big goal was to give more possibilities to load and offload data from a BeeGFS system and offload it to different storage types. As we know that customers usually have multiple storage systems in-house and using storage systems and file systems for different reasons. The BeeGFS is mostly on the front side on stretch and high performance, but may has some challenges if it comes to data management or long-term preservation or something like this. And what we do with the remote storage targets, we're expanding the file system on the back end to get more capacity available and to enable collaborative workflows where you can share data with an object storage and with other institutes to have access to these data and operate them. Another feature that we have for a similar way, it's a parallel copy tool. This is something we have included in the BeeGFS version 8, as the copy tool is something that leverages the benefits of a parallel file system and doing parallel copies between POSIX file systems. So it's also the same goal here to offload data or to load data into the Scratch file system as fast as possible to start the next job to get your data to a point where I have it accessible. This is something we want to talk maybe in a later webcast. Today, we want to be focused on remote storage targets and how to use them. As you know, we have a community and we have the BeeGFS Hive Enterprise solution out there. Remote storage targets is a feature that comes with the BeeGFS Hive Enterprise solution. So that means you need a license key to activate all the Hive features, not only remote storage targets, but also storage pools and others. Only want to mention in the community edition, you don't have the opportunity to configure remote storage targets. What is remote storage target service as from a technical perspective? It's an expansion of the file system. I already mentioned this. We want to have on the back end the possibility to load data and replicate data between the BeeGFS file system and an S3-based object storage. This can be on-premise, this can be a cloud provider like AWS. And the idea is here to create an opportunity to offload data with a single command without third-party tools, without having different software packages included here. Having a file system feature, a functionality to load data from a directory to an S3 bucket. We can do this with multiple S3 buckets. We can assign a remote storage target, so an S3 bucket, to a certain directory or to a certain file, and push and pull these data in and out from the file system. We can also create stub files. That means we can offload the data itself from the file system, but holding the metadata for the file still in our metadata services. So that means the user can see the files, they can search for these files, but the file does no longer take space on your Scratch file system. For most customers, this is something they are looking for, so to free up space on the expensive and fast NVMe tier and offloading them to an object storage where the data can be protected with ransomware protection like object lock or other stuff, versioning. And this is something we're supporting now with these remote storage targets. How works remote storage targets? As everything in BeeGFS, this is two services. One is the BeeGFS sync and the other is the BeeGFS remote, both running in user space on the BeeGFS client. So that means if I want to do this installation, I need to have a BeeGFS client that has access to the file system, and on the other side has IP access to an S3 bucket. And we're installing additional services here. We have the BeeGFS sync, who is really the data mover. The sync process is the one who is really reading from the file system and pushing the data to an S3 object. That means doing the put and get commandos from the S3 API. And the BeeGFS remote service is the one who is managing all this stuff. The BeeGFS remote service is able to manage multiple BeeGFS sync services. So that means we can scale up the sync services here to get better performance, to have more multiple connections to an S3 bucket or to multiple buckets here. And this gives us also the opportunity to leverage the benefit of a parallel file system reading multiple clients at the same time from a single directory or file. This is something what we're utilizing here. And the BeeGFS remote service is the management head for this feature, and the sync is the data mover for this. As mentioned here, we need connection to both sides. So we need to have the information, we have the IP connection to the outside world where the object storage is or the object bucket is located. And we need to mount the BeeGFS file system on these clients. The BeeGFS sync process itself or service itself has a small configuration file, but it holds no real information about the environment. It doesn't have any information about the object buckets or something like this. The BeeGFS sync gets all this information from the BeeGFS remote service, and we will see later that there is only a small effort to install this. The BeeGFS remote service itself is the management. For the management, we have also the possibility to store historical data about all the jobs that are done for pulling data, pushing data out, creating stub files. All this is handled in a large database or in a database that is handled by the BeeGFS remote service. And for this database, we need space. And our calculations show that if you have a very large system and having a lot of transfer actions on the system, we assuming that a maximum of 10 terabyte on data would be enough for storing all the information. So that means this client, where we're talking about the BeeGFS remote services installed, this needs some kind of local storage where they can put the database on and use this as a local directory for this remote service. The remote service can be installed on a dedicated server. It doesn't have to be on the client itself. It can be on a virtual machine or on a different server. It doesn't need access to the file system itself. Everything the BeeGFS remote service is doing is communicating with the BeeGFS command line tool and the BeeGFS service to push out the information about what job must be done. To install the BeeGFS sync service, it's quite easy. You install the BeeGFS repo, and then you install the BeeGFS client, if not already happened, the BeeGFS tools to get the BeeGFS command line tool on it, and the BeeGFS sync service on the system. Then we need the con-out and the TLS certificate that we also use for the BeeGFS command line tool to communicate with the management server and or with the BeeGFS remote service. This must be installed here on the sync. We need to disable the firewalls ports 9010 and 9011, and we should disable or at least set up the SE Linux configuration. As most of you may have heard before, we propose to switch off or disable SE Linux for BeeGFS installations. As this becomes more and more a request, we have now with BeeGFS 8.2 documentation on how to set up SE Linux together with BeeGFS. So if this is something you're interested in, we can also now support SE Linux on our servers for this. There is one specific thing that you need to remember if you install BeeGFS sync on the BeeGFS client. There is one additional line that we need for the BeeGFS client conf file to be activated. It's this bypass file access, and this will give this specific client special access to files that usually are blocked from the meta operation. As we offload files or if we push files to a cloud, metadata service has to be clear that no normal, I would say, usual client can access the file if they are offloaded. So therefore, to have these special permissions to do this, this is necessary to put this additional file in the beegfsclient.conf. All this information is also stored on our website. Here we have a detailed explanation on how to set up the RST components, but this is something I want to mention because we see this from time to time in support that people missing this feature. Okay. And from here, the BeeGFS remote installation is quite similar. You only need to install the BeeGFS remote package on your system and then configuring the BeeGFS remote TOML file. Here we have, and I will show this in a demo later on, we have the information about the management server, job worker, and remote storage targets. And then you start this service. Best case is you start this service after the sync service, and then the system comes up and we are ready to go with this. Usually this is already everything you need to know about the BeeGFS remote sync and remote storage targets. We have a short demo here. In this demo, we can see we have a BeeGFS file system running. It's a server called bserv. He has 2 targets, a metadata service running here. We have multiple clients, and we have one special client that is used for installing the BeeGFS remote and the BeeGFS sync services. This client has access to an AWS S3 bucket and to a local hosted MinIO S3 bucket only to showcase that both connections are working, and we can use on-premise or cloud storage for this kind of connectivity. Okay, then let's switch to our console. And here we see the output from the client. I have started already the BeeGFS health check. You see we have 1 meta, 2 storage services here. And from there, we want to start our journey. Let's check if we have installed everything. So we're looking for the list installed packages. What we can see here, you find the client, the remote package, the sync package, the tools for the BeeGFS command line interface, and here I have also installed the BeeGFS utils. The BeeGFS utils only have the file system check tool included, so that's necessary, not necessary for this feature, but it's installed on this host. And we want to see if we have all the information that we need to start the client. So that means we need the con-out file, and we need the certificates here. You can see this is a standard BeeGFS client. We have here the certificate file, and we have the conout file here on the system. We also see the key file here, but this is because we're starting also the BeeGFS remote server here on this later in this session. From here, we can have a look into the configuration file for the BeeGFS sync service, and this is stored in a tunnel file. Usually you don't have to change this configuration file, only want to change something in the configuration that is non-standard. What we need to know is the mount point, and this would be something where you have to be careful because maybe your system is mounted on a different point. So this is something the BeeGFS sync service needs to know, where to find the BeeGFS file system itself. Then we find a restriction here for the server and address things. Here you can restrict the access to which remote servers this sync process can communicate, and also changing the port where the communication happens in case this is necessary in your environment. This can be changed here, and the TLS certificate and the key file for the communication with the BeeGFS command line tool and the BeeGFS remote storage service. Another thing that is important is the BeeGFS sync service has a small journal and job DB. If a job is created from the BeeGFS remote server, this job is transferred to the BeeGFS sync service and then stored locally on this system. That means we have here a small database and a small journal that shows exactly on which status this job is. So all the files, all the chunks that needs to be transferred will be stored there, and with an information about if this is already done or not. This can be deleted if the job is finished, but if someone is killing the BeeGFS service in the meantime, or they lost the connection to an S3 bucket or whatever, there's always a possibility to restart the service or to come back with a connection, and then the system can go from there with the files that are not transferred before. So we do not do the complete transfer again. We have this database and this journal on the local system, and therefore we need also here a little bit of space to store this information, but this is really something less than a gigabyte. It's really only job information that we need for very, very large information, for very large jobs that we have to spread. It could be that it needs more than 1 gigabyte, maybe up to 10, but this is something we never saw in the field, but we know our customers are very, I would say, heavy users sometimes, and they have large jobs, and maybe we will see this in support or in real life. If customers heavily using these tools, we will also see bigger jobs and journal DBs for this. Last but not least, the remote certification file and the certificate for the communication with the remote service here. Don't need to change on this one. Next thing what we want to do here is we want to activate the service itself. So system CTL and we have a look if this is started. Here we are, system is up and running. Next thing what we need to check is our BeeGFS remote tunnel. And here we see also the information about the mount point. Where is the BeeGFS mounted? It could be of interest if you have a different mount point in your environment. We need the management address from the BeeGFS management server and the standard port that this is communicating, the conout file for communication, and the certificate for the TLS encrypted communication between the remote service and the metadata, the management. This is quite standard here. Then here we have also the possibility to change the address to which sync servers the remote can talk, and if there is an encryption for this communication. It's important because the BeeGFS remote service is the only one who has the credentials for the S3 buckets, and the communication between the S3 remote and sync service should be encrypted. That's why we recommend to use their self-signed TLS certificate for this communication if this is on a different network. Here we have also the path for the job database and for the history. So as I mentioned before, the BeeGFS remote service has also a history about all the puts and gets and transfers that are made into the cloud or in on-premise object storage. And therefore, we need here a dedicated database. This is stored on standard Wallet BeeGFS remote path badger, but it could be that you have different requirements if it comes to capacity, so you can change the database here so that the remote storage service has enough space to do this. What you also configure here in the remote TOML file is the workers, and the workers are the server where the BeeGFS sync service is running. That means we have here one sync server only available because it's a small setup here, but you can have multiple servers, as you can see, here's already prepared for a worker 2 and 3 and so on. What we need is the name of the server and the port that is listening to the certificates for the communication. And that's what we need here. The next thing what's interesting is we configure here all the remote storage targets that we are trying to communicate with. In our case, we have one remote storage target that's based on a local MinIO configuration that I have here in our lab. It has an ID number, a name, it has an IP address and a port where to communicate, the typical information about the region, bucket, access key, secret key, and so on. And we have the same here as ID2 for a remote storage service target as an S3 bucket in AWS. You can see that's our standard communication here. So these are the credentials that you have. And these are stored all in this remote TOML, BeeGFS remote TOML file, and nowhere else. So if you have the sync service on a client where other users may have access, they don't have access to these credentials for this. That's why the reason to do this separately. Okay, that's all what we need to know about the BeeGFS remote service. And then here also we start the BeeGFS window, the BeeGFS service, systemctl start BeeGFS remote service, and go for it. Let's see if this is started. Looks good. And this is everything you need for this setup. So you need to install these both packages. You have to be sure that you have the TLS certificate that you need for the communication. And then you have to configure the BeeGFS remote TOML file with the information about where is the sync server is running and about where is your management and which remote storage targets you want to add. If you want to add additional S3 buckets to your configuration, you can add them, restart the remote service, and everything is fine. No impact on the sync servers as well. And don't forget to change the file for the client. That's something I want to show also here. That's a standard non-tuned BeeGFS client on my environment. We have the information about the management, whereas the management service is running. And here we have a dedicated line. This must be added to the configuration to give this specific client access to these special data handling features that they need. Otherwise, a standard client would be blocked from accessing files if they are only stubs. That's important, and therefore we need to check this. If we have now everything already done for the configuration, we can start to use the BeeGFS remote features. And for this, we have the BeeGFS command line tool that comes with version 8, BeeGFS, and then remote. And then if you don't have any idea, do tap, and then you will see what kind of options you have with the remote process. You have jobs where you can see what's going on at the moment. You can say pull and get from or push and pull from the S3 API. You can see the status of a specific job or file, and you can list all the storage targets. And it was what we're starting with, BeeGFS remote list. And here we see we have two storage targets configured. One is the MinIO, that's the local one, and one is a bucket in AWS that we are using here for this demo. But this is, you can also have more than this for your environment. Okay, how working the remote storage targets together with directories? Usually we have a BeeGFS entry command into our version 8. And here we can see the entry infos for the directories. I have prepared 3 directories here, RST demo 1, 2, 3. And you can see the entry ID, type directory, where it is stored on the metadata, where the storage pool, and so on. These are familiar information for you. But here we have on the last column, we see remote storage targets, and you can see here there is a none. That means if you can assign a specific directory with a specific remote storage target, and then it's easier to push and pull data from and to, because this information is already stored in the entry information for this specific directory. And this is what we want to do right now. We want to set this information, so BeeGFS entry set, and then we say remote targets equals 1. That means we, for this specific directory, RST demo 1, we want to have the MinIO storage as a local, and we want to have this for all files that are already included here. So that means we can expand this with recurse, and this means it will be do everything on this specific directory. But as this could be a lot of files effect, so we always need to set a yes behind so that we can run this. And you can see processes, 30 entries. That means we have, with this single command, set this as a default value for all these files inside this directory. All new written files to this directory will also inherit this from the directory and will be assigned together and associated with the MinIO remote storage target bucket. Okay, we want to do the same for a different directory. So we have here, and we want to send this to the AWS. So everything that goes to the BeeGFS RST demo 2 directory will be assigned to an AWS account. And therefore we set this here also. And there is the moment 3 entries. That means it's a directory and 2 files included in this directory. Okay. And we can see the information already. Here with BeeGFS entry info, you will see this directory is associated with the MinIO, the other ones with the AWS account that is configured here. Okay. And the first thing I want to do is I want to push some data from my file system directly to our MinIO bucket. So for this, I need the BeeGFS remote push command. And what I need to do here is only giving the full path name for this. As we have this remote target already assigned to this directory, that's the only thing I need to do. We got here an information back. So you see nothing synced, but scheduled here. And after a while, we can check this and we will see that this is already done. So let's go to BeeGFS, remote status, and then giving the complete file name or path. And you can see here, error, no, not all files are synchronized, but this means the system is still working and pushing these data to an S3 bucket at MinIO. Let's check if this comes on the system. So we have here a small tool. You may be familiar with this CyberDuck thing. And let's check here on our MinIO. We have a test bucket. And there is a new folder here called RST demo 1. You can see it's from today. It's already 5:30 in Germany. That's why we see this timestamp here. And if we do refresh, you will see that the files come step by step into this folder. Yeah, my lab is not really, I would say, a high performance thing. My laptop is connected over Wi-Fi. That's why it takes a little bit of a time to get this information here or to move this data. But if we are doing refresh again, you will see that these files coming step by step. And you also can see this with the same status. You see that it becomes less jobs not completed. So it will work on this list until everything is done. And then all the files are pushed to this local S3 bucket that I have here installed on my MinIO stuff. I mean, this is quite easy, but if I look into my directory, nothing has changed. So the directory is still there. The files are there. Nothing has changed, but I have all the files here from the size are still there. I have a different directory. And here we have two files. It's candidates and test quota. And as you can see, they utilizing here something around, what is it? 52 megabytes in size. So, and I want to push these files into a cloud storage and removing the content and only have a stub file available for this. Therefore, I use the same command, BeeGFS, remote, push, but I give an additional command here that's called stub local, and this says to the command, move the data to an object storage and hold only the metadata information for this file as a stub file here on my local storage and free up the space. And therefore, I will give folder information here. And with this, I can push it out. There's also verbose output that we get a little bit more information. And if we now looking for a status, we can see what 0 synchronized, but there are the directory. But if we do here the files itself, we see 2 are offloaded. So the system is already fixed. So we can now have a look into this and see what's inside our directory. And as you can see here, the space used on disk is only 1 byte. So this is only the information. We store the URL, including the name, into this file. So this is the only thing that stays here. So this information here is readable, and you can find where we have exported this file. You can see it here. The file was 52 megabyte, and now the size is only 1K. So only the information what's included here. for now, we should then be able to remove the data. So, and not remove, you should check the data back. But first, we want to see if these files are really here. So let's connect to the AWS account. Okay. Takes a while. And here, we should have our directory. Okay. Go back. Maybe I have done the wrong. No, there. Let's see what we have, what I made on a mistake. We have here remote push local RST demo 2. That's fine. It's pushed. It's there. It's offloaded. And we should see our files in AWS. It seems that I have some challenges here with my connection. No. Come on, guy. It seems that my CyberDuck is not really starting here. Let's try it again. Let's see what we get now. Otherwise, we may have to wait until this is updated here. Can take a while until you see this here. But let's try to get this data back. As we see, we have only the metadata information stored on our system. So what we need to pull back this information, and therefore we use the same or a similar command here for this. Let's go for this. We go here with a command that's called BeeGFS remote pull. We give the information about from which remote storage target we want to have the information, and we see here the remote path for this. Here we have to change this to and from there we should pull this back from the AWS. That's a standard output, so the information about what's going on here and what is the actual status for this. We see that there is one scheduled, and then let's see how this works. We have two entries here for this, and one is synchronized. And if we do an ls minus copy, we see that the candidates have their values back. So the whole file is back from here. We see it here, the size is different. And then we see here, this is now updated here. That means we can now have a look into this file. This file is still available and we can have access to it. That's something that can be helpful if you want to offload data, if you want to free up space on your system. You can push this, leaving only a stub file belong, and then pulling it back in case you need these information. Another interesting thing is, and this is something, if you share data with other scientists or with other institutes, and you may need to import data from their object storage. Therefore, we have the possibility to import data, only the metadata information about the content of a bucket. So for this, we can also pull objects from an object storage, but only pulling the metadata, creating virtual files that are empty, more or less empty on our side, and putting this into a directory to search which files are available for this. And therefore, we have the remote pull command, again with the stub local. That means don't move data, only create stub files here. We say where these files come from, remote target 1, and we have there a remote path. That means these paths must be exist or on the bucket, on the storage where we are looking for. And we can also work here with an asterisk to say, pull everything that comes with this. We're using the slash in the file name and the path name as object ID. I mean, everything that we push into an object storage is the complete path name, including the file name, and we interpreting the slash not as a directory, but this will be during the import, we will create directory structure out of it. So if the objects in the object storage have this slash in the object ID, we will create a subfolder for this and then putting this as the same way like we do it with a file. And from here, we can now import all the information that are stored in these different, or it's in the same bucket, but it has a different prefix. In this kind, it's a prefix on what we see here. There is something called second, and this is what we use here for our prefix. And now we should have a look into the directory that we have here. And what we can see, here we see the content that we also see here. This is imported. Everything that belongs to this is imported here. And we see candidates, test, second quota, and so on, files that we want. And I want to have only the information or only the files that has in the name test quotas. So that means if I want to do this, I can do a BeeGFS pull in, but without the pull stuff. So what I do now is I only import the data that has this. Yeah. And see what's happened now. Let's go to status. Okay. And see if the files are there right now. And here we can see these files are downloaded. All the other files have only the metadata information here, but these files are downloaded. And see here the size of the original files. So I have ordered only information about the bucket content and then only download that I like to have for my specific job that I have to run. And from there, we can operate this. This option on how to push, pull, and import stub files or metadata information. And for this, we have information stored in our job history. So as I mentioned before, we have a specific there on the BeeGFS remote service, and therefore I can say BeeGFS and then giving the directory where the data is stored. And if I do this here for my demo directory, I can also say reverse, and then I should say, okay, what happens? You can see, okay, these files here were up to a remote start. If I do the same, my second area, I can also see, okay, these are downloaded and some of them is loaded. That means the candidates file was downloaded. The test quota is only the import of the metadata, and that's why it's offloaded and not available here. The last directly we can that these files are downloaded, and you see some of them are only downloaded metadata information. And if you don't like these cloud symbol and all the emojis here, you can also say disable emojis, and from there you will get something that you can pause, that you can hand over to a script or whatever you want to do with this kind of information. That's all for my demo that I have scheduled here. We'll see if you have some questions. I want to hand over to our Q&A session.
Okay, Ingo, there's not too many questions. I think
Okay.
one is an easy one. S3 Glacier support with RSTs, and probably on a broader scope on what is tested so far and which direction we are going.
S3 Glacier API is implemented in the next BeeGFS release. So this will come out maybe in a few hours, maybe in a few days. It's 8.2 will have support for S3 Glacier. We have tested this on multiple local things, but we're also supporting third-party storage appliances like Crowd Data Extreme Store, for example. If you have an user customer that has some kind of S3 on-premise archive that supports Glacier, we are happy to do some tests there to see if this is supported. As we know, S3 is not really a standard. There are a few flavors and not all features are mostly supported. That's why we are happy to do this. But in general, S3 Glacier support is included in the next BeeGFS release.
Okay. And the other question, I'm not 100% sure if I understood it correctly. It's more about the specification for the type of packages someone needs to install on nodes like compute node, GPU nodes, master nodes.
On the compute nodes, you have mostly only the clients to install, so that's standard like it was with BeeGFS before. The only thing that you need a client that has this BeeGFS remote and BeeGFS sync installed, and you have, as I mentioned, you can install the sync on multiple clients that must have access to the S3 buckets, but nothing changed on the meta storage management side. So the BeeGFS storage cluster itself is completely the same way like you have it today. If you have already an installation running on BeeGFS 8 or 8.1, you can update this and then add only these two packages to give this functionality. If you are on a 7.4.6 or 7.4.7 release, you can update to 8 and you have all the features available with 8.1, 8.2 with this. So there is no change on the configuration for meta storage management or something. The only thing we change is really these two configuration files, BeeGFS remote and BeeGFS sync, and adding one line in the BeeGFS client where the sync node is installed. Nothing changed on the cluster configuration for the storage server.
Good. Question from my side. Where is a good point to start with if someone is interested in the RST functionality and where you can find further information?
Usually the best way to start is our website, beegfs.io. You will find there installation documentation latest, and there is also a section for remote storage targets. There's a step-by-step introduction and documentation how to install it, what you need to do to get this up and running. And there's also a good, if you have installed this, you have the BeeGFS built-in help functionality. So every time you do something on the command line, you can do it right. You can ask for help, and then you see additional information here. For example, if you want to do a push and you want to know which options do I have with this, I can also say here, help, and then I get the information on what is available for this, which remote target I should know, if I have stub files or not, and all this information is online. But the first thing to start with, I would always recommend to go to BeeGFS.io documentation latest, and then you will find all the information there. Or you can reach out to me if you have general questions about compatibility, targets we have tested already or not. That's something we can answer. So if you write an email to my personal email address or to consulting@syncproc.com, it's also something that we can handle, and we can reach out to you and check how we can help with the implementation.